Okay, so on the last time we talked about a vector being made up of three components, the I component, the j component and the k component. What we want to be able to do now is to add and subtract vectors. So what I've got is just a simple exercise with three vectors, A, B and C, which I want to have a crack at adding them. So what I'm going to do is, I think you just will do this intuitively. I don't need to really show you. It's what you imagine is right is almost certainly right. So what I'm going to do is just grab a bit of paper and have a go at working out A plus B and A plus C and B plus C, and I'll give you about 30 seconds or so to have a go at it, and once the 30 seconds is up, then I'll show you how it works. So grab your paper and on your marks, get set, go. Your 30 seconds starts now. Okay, it's about 30 seconds, so hopefully you'll be able to add those things. If you didn't quite get them finished, it's the idea more than the actual doing the numbers that count. So let's have a look at the answers and see if what you thought was intuitive was actually right. So here's the answers. So A plus B, all you need to do is just add the two I bits. So 2i and 3i is 5i. 5j plus negative 4j is 1j. And negative 3k plus 7k is 4k. For A and C, we're doing this one, and notice here that 2i and negative 2i is nothing, so we have no I component in A plus C. 5j minus 3j is 2j, and negative 3k plus 2k is negative 1k. And for B and C, 3i plus negative 2i is 1i. Negative 4j plus negative 3j is negative 7j, and 7k plus 2k is 9k. So I'm hoping that was just the way you thought about doing it. It sort of always struck me as just kind of intuitive. You really just do it and it makes sense. And subtracting is basically exactly the same. So here's a go with the same vectors and doing a subtraction. So again, let's give you 30 seconds to see how you go. So 30 seconds starting from now. Rightio, hopefully that was not too painful. I always find subtraction harder because you end up having to subtract negative numbers and it tends to cause some entertainment. But let's just have a check and see what the answers were. So same idea. So 2i take away 3i is negative I. 5j take away negative 4j is 9. Negative 3 take away 7 is negative 10. And A and C, 2 take away negative 2 is 4. 5 take away negative 3 is 8. Negative 3 take away 2 is negative 5. And likewise for BC1, 3 take away negative 2 is 5. Negative 4 take away negative 3 is negative 1. And 7 take away 2 is 5. So adding and subtracting vectors, pretty straightforward. Just add and subtract the relevant components. And the only other thing I want to look at right now is be able to deal with scalar multiplication in terms of addition and subtraction. So again, I've got some simple examples to do, same vectors. I just want you to multiply them by scalars for the first couple, and then for the last one do a bit of scalar multiplication and subtraction. So last time, take 30 seconds and see if you can crack these ones out starting from now. Rightio, and that's time. So again, I'm pretty sure it's just what you do intuitively, just do it component by component, but here's the answers. So for 3a, you just multiply everything in a by 3. So 2 3s are 6, 5 3s are 15, negative 3 3s are negative 9. For negative 2 lots of c, so we're taking c here and multiplying it by negative 2. So negative 2 times negative 2 is 4, negative 3 times negative 2 is 6, and 2 times negative 2 is negative 4. And then for the 4b minus 5c, you're just doing 4 lots of this one, take away 5 lots of this one. So we're doing 4 3s are 12, take away negative 5 lots of negative 2, which is adding 10, so 12 and 10 is 22. 4 times negative 4 is negative 16, and then we're going to go into effectively plus 15, which is negative 1, and 7 4s are 28, and then we're going to minus 10, which is 18. So hopefully you just find that addition, subtraction, and scalar multiplication of vectors is just what you do intuitively. That's it really, simple as that. Next time we'll move on to something different.